All right, in example 29, we're going to solve this 3x3 system of equations using Gauss-Jordan elimination. Basically the same strategy we employed for those 2x2 systems in the last section. And our first step, as you know, is to write the matrix that represents the system. Now our first goal is to get a 1 right here in this top left corner. We want a 1 there. And the easiest way that we can accomplish that is just by swapping out rows 1 and 2, just interchanging those two rows. Now that we've accomplished that, then what we want to do is zero out the entries below that 1. So we want a 0 for both of those numbers. Now we can actually do this. We're going to take two row operations, one for zeroing out the 3 in the second row and another one to zero out the 2 in the third row. But we can do those sort of simultaneously. So let's see what we get. To zero out the 3 in row 2, what we're going to do is take row 1 and multiply it by -3, add it to row 2, and put the result into row 2. Row 1 is unchanged. So -3 times 1 plus +3 is 0. No surprise there. -3 times a -2 is a +6 plus 1 is 7. And for this entry here, we have -3 times 1. That's a -3 plus a -2. That'll give us a total of -5. And right here, we've got -3 times 3. That's a -9 plus 2 is a -7. And so there's our row 2, and like I said before, simultaneously sort of in one sort of set of row operations, without having to redraw a whole new matrix for this, we can zero out that entry in the third row where the 2 is also. And to do that, we're going to use the row operation multiplying row 1 by -2 and adding it to row 3 and putting the result in row 3. So of course that zeroes out that entry. That's how we chose that row operation. And let's see what goes here. -2 times a -2 plus a -1. Let's see, that's a +4 plus -1 is 3. The element that goes here, -2 times +1 plus a -3 is a -5. And right here, we're going to have a -2 times, let's see, in row 1, we've got a +3. So -2 times 3 plus +3. So -6 plus 3 is a -3. All right, so this is our matrix now, and what we want to do, we've got this first column, that 1, 0, 0 down the first column. That's looking exactly the way we want it. So we're ready to move on to the second column and obtain a 1 right here. Now, before we do that, I'm just going to clean up some of this arithmetic to make room for a row operation. Now, what we're used to doing in these cases when we want to get a 1 is just to multiply through by the reciprocal, if a row swap won't work. And so we could multiply through row 2 by 1/7. However, we're in a situation right now where we can actually avoid doing that. Not that we're afraid of having to deal with fractions or anything, having the -5/7 that would end up right here. But we can actually keep working with these whole numbers, because if you take a look at what we have in row 3, it's really important that this number here is available in a row below the 7. We can obtain a 1 where that 7 is if we take -2 times row 3 and add it to 7, because that would be a -6 plus 7, which will give us 1. So let's go ahead and do that. It's important that this 3 that allows us to do that, the 3 that we have right here, is below that 7, because I've already got a 0 there, and I know I'm not going to mess up the 0 that I have in the entry above. So row 1 is unchanged and row 3 is unchanged in this process, right? Row 2 is the only row that is actually being altered here. Let's see, so we have a 1 there, and now -2 times a -5 is a +10, plus a -5 is a +5. -2 times a -3 is a +6, plus -7 is a -1. And here we are at our next matrix. We've got the 1 where we wanted, and now our goal is to zero out the other entries in that column. So the -2 that's in row 1 and that 3 that's in row 3. So to zero out the -2 in row 1, we're going to multiply row 2 by a +2. Add it to row 1 and put the result in row 1. And to zero out the 3 in row 3, we're going to multiply row 2 by -3. Add it to row 3. Put the result in row 3. And the row that is not being changed in this process is row 2. So that's going to stay as it is. We know that column 1 is not going to be changed in this process because of how we're going about it, so we can actually put those entries in. And we know that this is going to zero out. That's how we chose this row operation right here. Now 2 times the element in row 2 to get that third entry here, 2 times 5 plus the element that is in row 1. So that would give us 11. And right here, 2 times -1 plus 3. So that's -2 plus 3. That's a +1. Moving on to row 3. We know that, of course, down here we're going to get a 0. That's how we chose this row operation. And let's see, for this third entry, we'll have -3 times 5. That's a -15 plus a -5. That's -20. And right here, -3 times -1 plus a -3 is 0. So let's see, before we write our new matrix, I'm just going to clean up this arithmetic a little bit. So now we have columns 1 and 2 are all set. We're ready to move on to column 3. And we know, of course, our goal, let's get a 1 right here. Now, unfortunately, there's no rows below this that I could perhaps use a multiple to get that 1 that's right there, other than what we've used in the past that will result in fractions. Multiplying that row, row 3, by the reciprocal of the number that's there. So we got to multiply row 3 by minus 1 over 20. Rows 1 and 2 are unchanged. Row 3, multiplying through by 1 over 20. Or negative 1 over 20, that'll be a positive 1, and that'll be a 0. And now, even though we did have to go through and use the reciprocal, we still didn't end up with fractions, so that's kind of convenient for us. And now we're ready to finish this up because we know we're on to our last step in this process. It does take a while to go through all this, but we're almost done. The only thing left to do now is to zero out those entries there. And so to zero out the 11 that's in row 1, we're going to multiply row 3 by negative 11. Add it to row 1, put the result in row 1. To zero out the 5 that's in row 2, we'll multiply row 3 by negative 5. Add it to row 2, put the result in row 2. Row 3 is unchanged in this process. And of course, the fact that we have zeros in row 3, that we've got zeros right here, means this row operation, these row operations aren't going to affect the entries that are above it up here. So we know what that's going to look like. We chose these row operations in order to give us zeros right here, so there's not a whole lot to do. We know that those entries will be zeros, and the only arithmetic really that we have to do is to figure out what's on the right side of this vertical line. So let's see, negative 11 times the element in row 3, which is 0, plus the element in row 1 is 1, and that'll give us 1. Of course, the fact that we have a 0 down here is kind of convenient for us, at least sort of as far as doing calculations goes, because we know that that's not going to change the elements that are above it. In fact, so we should expect that we are going to get a negative 1, the same element that was there to begin with. So you can do a quick check. Negative 5 times 0 plus negative 1 is in fact negative 1. And now we have our matrix in this reduced row echelon form. And this means that our solution is x1 equals 1, x2 is equal to negative 1, and x3 is equal to 0. Again, as we've done in the other matrices and in the other examples, you can check this on your calculator. If you enter this matrix into your matrix A or B or whichever one you choose, you can have it go through the process of finding the row reduced echelon form, and it will in fact confirm that this is the solution to that system of equations.